Okay, so I'm going to build up to this blog about building generative trending recommendations, but I'll and also sort of created slides to for the story to be a little more succinct.
Okay.
But I'll start with our previous post,
Yeah.
you know, and this obviously implements the Tiger paper.
Yeah.
I'll talk about that, and then somewhere here we are going to talk about that, and then I'll talk about what is different in the OneRec paper.
Go ahead.
There's a lot of evaluation, a lot of details that we can go into as the topics come up, and
Yeah.
but then I will also like my main idea is not to just replicate. I'm trying to see how to, for a specific domain, take example of trending here, trend recommendations,
Mhm.
how to translate their ideas, what else to add, so what to do above OneRec in terms of generative trending recommendations.
Right.
Okay. So to start with, we talked about, like we talked about last time, generative recommendations means instead of the different models of retrieval, early stage ranking, value model, list optimization, etc.,
Mhm.
that people have, um, and can we have a single process that directly outputs a list of recommendations?
Right.
And and this is inspired by how LLMs, or particularly the encoder decoder architecture of LLMs works. That it takes the context, it takes the history, it summarizes it. Sometimes the summary can be of the same length of this, like in machine translation. It is not necessarily a shorter summary, but it is still a summary. It's still a processed version of the inputs, and the decoder attends on it, and then has causal attention on the generation to produce the predicted tokens, which then you have a loss with the ground truth using classification.
And
Yeah,
just to cut you a little bit. So,
yeah.
in fact, when I was reading it, I thought to myself, this looks so much like a transformer architecture.
Hmm.
Because it is a encoder decoder. But then I saw something in there
Yeah,
which kind of made me think that possibly this is not. I might be mistaken. Let me.
yeah. Tell me which part.
Um. Yeah, there's an actor. Yeah, there's an actor between. There's an actor. There's a summary between encoder decoder.
Right,
Um.
right. Which, yeah. Tell
Yeah.
me what
So
to.
that's the part where it got me a little bit.
No. I'll
Yeah,
I
yeah,
will
yeah.
walk you
Then the
through it.
part
That's a
about maybe I don't know whether we'll get to that part. The reward model, the
so
reward function on the end.
the the reward model. Okay,
Yeah.
let's
So
do that. Let's
I
actually.
was reading your blog and you were saying something about if you want to maximize sessions, if
Yeah,
you want to maximize, let's say
yeah,
DAO.
yeah.
So I was curious about that. Just if you could
Okay, okay.
touch a little bit on it.
Okay. So two questions. One is, what is the summary?
Yeah.
And secondly, what is the reward model?
Right.
Okay, we'll definitely deep dive into that. And they are actually very important. They're probably the crux of what they've done.
Yeah.
So this is a high-level architecture of LLMs. One good thing I like is that the OneRec paper has really faithfully um, reproduced it, and not to mention the Tiger paper also does the same.
Yeah.
If I look at their like this is also similar. They take their inputs and then they encoded context, and then they have the decoder.
Correct.
So there's a lot of similarity, but we'll come to what is extra.
Yeah.
Yeah, so we talked about the four parts of generated recommendations. First, you need to tokenize, then you need to encode the context,
Mm-hmm.
Then in training, you need to kind of decode probabilities and do softmax loss. And in inference, you need to do beam search and one by one generate.
Okay.
And to ensure that you're moving in the right direction, you have to encode the reward in the system.
Yeah.
Right? This is what we talked about last time. It's,
Yeah.
I'll also link it in our video for those who
Of course. Yeah.
who might not have seen it. But coming back, so this is probably the main point we want to see. What is extra? What is different in between OneRec and Tiger?
Mm-hmm.
So first thing they do is, actually, let me just show this. They develop a better tokenizer. Okay. And what is different about the tokenizer? Now, again, all of this is my interpretation. So they were
No. Just
some disclaimers.
Yeah, it's fine.
Okay, so where is the tokenizer? Yeah, tokenizer. So they start with the same multimodal embeddings that the Tiger paper also did, but they use RQ k-means instead of RQ VAE.
Yeah.
Right? This is an interesting part. They say that we integrate multimodal content, but they also align them by collaborative similar pairs. And this is important because when we talk about generative trending recommendations, we'll change it, right? So imagine there's a user who's watched a video and in the same session watched another video. Look, a very common assumption, in fact, probably one of the most successful like retrievers in the traditional cascaded recommendation system is called item-to-item recommendation, which takes these co-watched videos. And I think one of the first papers was the Google Watch Next paper, YouTube Watch Next paper. This was the seminal paper. I recommend you to read it if you haven't. I think it also introduced the concept of shallow tower for bias, and a lot of great ideas. But coming back, you will see this idea of, hey, let's take video watches in the same session as an indication that they are similar.
Okay.
Now, this is different than what Tiger did. In Tiger, you just start with your multimodal LLM representation. But in OneRec, there's OneRec. Actually, there are two OneRec papers. There's the smaller paper, and there's the technical report. I'm mostly focusing on the technical report today. They take these.
Yeah.
Sorry, you were saying?
I had a quick question, but go ahead.
Oh, yeah, okay. They take these co-watches in the same session,
okay,
and then they minimize they maximize the similarity of the embeddings of the co-watched videos, and this is like in batch loss. So item to item loss. So they take collaboratively similar video pairs, the same ones that are watched in the same session, and they have a loss that these should be closer than in batch negatives. And they have something about caption generation also. Yeah, we can talk about that.
Yeah, so I was curious about what you just mentioned about videos in the same session.
Yeah.
So if you're building a traditional, let's say, two-tower network,
yeah.
How do you capture that?
Yeah. So in traditional recommendation retrieval, there are two broad classes of retrieval. One is called user to item, and the other is called item to item.
Right.
Okay. So for user to item, you don't directly capture that. In user to item, you have one tower, which is the user tower, the other is the item tower. The benefit of user to item is that if you have a lot of history of the user, then you can really understand the user well. Like you can get a lot of nuance.
Correct.
New, let's say I've watched 1,000 videos, and one of them is a video of, I don't know, curling or something.
Yeah.
Okay. Then when you see a new video,
Yeah.
you can really pinpoint it. Oh, there is a video.
Yeah.
Like you can do what is called target aware attention or decoder attention,
Yeah.
right?
Yeah. Yeah.
But imagine you are now recommending for a new user. They have zero
Mm.
history,
Mm-hmm.
or rather, they have watched a single video. Yeah, I think you need some history for recommendation. But anyways, let's assume they have watched a single video. Chances are you won't be able to, like, the normal machinery of your user tower will not model it well. What you can do is just basically watch next given this video. You can model this,
I see. I see. I see. I
right?
see. I see. I see. Okay.
And the way you do it is you take your pairs of videos that are watched in the same session, let's just say,
Mm-hmm.
and assume they are causal or interchangeable.
Yeah. Yeah.
And then you model it. And then you say, hey, can I find a good either embeddings or like tower or whatever way to model these videos so that the representations are similar? So exactly this loss function.
Mm. 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 Okay. Makes sense.
And why are they doing this? They're doing this because if they actually have a lot of data of actual watches, so they found that not just using the LLM, like the multimodal representation, but complementing it with actual watching behavior makes them find more semantically closer videos.
Mm. So can this be applied to friending? Because I'm thinking, if I, for example, people you may know, if I follow you,
Yeah,
and then I follow the next person I'm going to follow,
yeah.
that can be a little bit, maybe those two people might be not similar because I might follow maybe a creator right now.
Ah,
I follow, let's say, The Rock or some musician. The next thing I see you as my friend recommendation, I follow
yeah,
you. So you and that musician might be a little bit
yeah,
not similar. So I'm wondering whether there's a way.
yeah. So I think what you described is no different than in videos. Like I could
Mhm.
watch a soccer video, and after that, I could watch a music
Correct.
video.
Uh-huh.
That assumption of similarity, I don't have a good idea whether it is more or less applicable to
Yeah.
friending. Uh, but but I think one difference I can see is that in videos,
Mhm.
the item being recommended are of the same type, but the actor is not.
Could you expound on that?
So if I am the person watching the video, I'm
Mhm.
like a user ID, and the
Okay.
videos are video IDs.
Correct.
But in trending, all three of them are user IDs.
I see. I see. I see. I see. Okay. Oh, I understand what you're saying. Okay. Yeah.
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 So I think it gives us not just the hey, these two are similar, but it gives us the indication that all three pairs are similar.
Hmm.
Right?
Then I would argue that's even better.
Yeah, I agree. I agree. In fact, that led me to feel that all the papers that you'll read,
Hmm.
obviously not disclose anything proprietary, but all that we know about friending recommendations, they typically they mostly look at this link. Hey, a user made a new friend. These two must be similar. They actually almost never have I seen them use this link.
No, yeah, same case. That's the reason behind my question. I've never seen that before.
Yeah, yeah. Uh, there are some tricks. This is actually related to traditional graph learning, and there are some tricks that um, help find the weight of this link. For instance, imagine this is an extremely popular item. Okay, now I'm talking let's say videos. Let's say this is, I don't know, yeah, a popular music video, and this
Hmm.
is a niche curling video. Yeah, curling is a thing
Yeah,
today.
yeah,
But
yeah.
anyways, then when you build this link, you will find this on the left side and this on the right side very rarely, but you'll find this on the left side and some other videos on the right side a lot. So um, this basically makes the causality of a popular trigger low. Like a popular trigger, it almost doesn't matter if a popular trigger is there or not.
Mhm.
This is called the trigger and this is called the item. So this is
Okay.
also called trigger to item retrieval. And the triggers that make most difference are ones which have a lot of information, which means that the probability density after watching the trigger is concentrated.
Okay. 1 second. I don't know why this camera keep doing this. I am not quite sure. Keeps disconnecting.
No.
Yeah.
Yeah. So, but I'll kind of move on to the one aspect here that they improved, or rather they changed, is that compared to the Tiger YouTube paper, they make a better tokenizer. And the two aspects that they say is better is one is that they use this collaborative loss based on co-watch. And they say RQ k-means, residual quantized k-means, is leads to a more balanced. They're nice ablations. There's more than balance. There's some metrics as well. But anyways, leads to a better tokenization than RQ VAE, residual quantized variation auto encoder. Okay. Now this part we don't need to change. Is for friending recommendations, this part can be normal. But the collaborative loss, like we were just discussing, I think we can try to customize it to the fact that all three are users. Hey, I can't hear you.
Can you hear me now?
Yeah.
Yeah. So I'm saying on the k-means, I'm wondering how they optimize or how they train that during training, because not unless you don't back propagate. Oh, I'll look into those details, but that's something I'll find out, because the formula of k-means is not differentiable.
No, so essentially, they kind of do
Oh, I see.
definitional.
Yeah, okay. I see what they are doing. It's actually the answer is in the formulas you are showing.
Okay. I don't
Yeah.
think they. Yeah, they basically get the embeddings and then they cluster. I don't think they get lost back.
Yeah. It's not, it's k-means, but it's a different sort of
Yeah.
formula. It's not,
Yeah.
yeah, kind
Yeah.
of the
Yeah.
way we traditionally used to do it.
Yeah. So the interesting point is, and again, I'm putting the lens of what needs to change if we build generative recommendations or friending.
Mm-hmm.
Uh, let's say there are three parts, right? There is the tokenizer,
Right.
there is the encoder,
Uh-huh.
decoder. Tokenizer needs to change. We talked about the collaborative loss and
Yeah.
like in case of let's assume the tokenizer will customize, but the encoder actually there is no difference per se. Like if you look at the encoder, where is this? If you look at the encoder, they don't really do anything very different than a traditional retrieval. I'll explain what I mean.
Yeah.
And then I think it is also your question, how do they summarize? So encoder, yeah, let's start here. I remember last time you said, let's start with the forward function. This is
Yeah.
like the first point of the forward function after this will branch off.
Okay.
So their summary is a concatenation of the encoding of different parts of the user history plus a positional encoding. The I'll focus on two parts here. One is the long-term history, and the other is the short-term history. But just for completeness, I'll mention the other ones. So you have, one second, they call it the pathway. You have the HU, which is just the things like age, gender, user ID, etc. The static. And they have the short-term history, which you can say recent watches. Okay. And the inputs here are, this is just a concatenation of the most recent 20 user interactions.
Okay.
But these inputs are very standard, the video identifier or the tags and timestamps and playtime and things like that. Like if I ask you today, hey, let's build a new kind of state-of-the-art two-tower model, we'll also use the same user history. Yeah. Use the video sequence, video IDs, and playtimes and all that. And this is a normal encoder, nothing different. Okay, and they process it in some of these encoders. They process it through a transform architecture, but let's call that a detail. Basically, the short-term pathway is nothing but they input a sequence of 20 items, process, and the output is also a sequence of 20 items.
Sorry, say again.
For the short-term pathway,
right.
Short-term user history, they take the most recent 20 user interactions.
Okay. Yeah.
And just like we wrote in our encoder-decoder architecture of machine translation, once you have those 20, once you have the context, you pass it through some sort of attention, but the output is of the same length.
Okay.
So here the output is also the same length. The HS, this is the representation, final representation, is also of the same length.
And then the D model. Okay.
Yeah. So that's what I wanted to point out, that the short-term pathway is nothing but a encoding of the sequential encoding.
20.
The last 20. Positive is similar to short-term. I'm not focused on that. Lifelong is interesting, where they do some clustering and stuff like that. It's very interesting, but I'm going to skip that. But this part is interesting. They summarize the long sequence through what they call the Q-former architecture. What is that? In your init function, they initialize NQ, which is 128.
Okay.
And then parameters like query vectors.
Yeah.
And these are, of course, trained through the model. And so you have KQV attention, where your QKV attention, where Q is these 128 vectors. And the K and the V is this long history.
I see.
So imagine these queries are like filters. Let's pretend they are like different interests or something. And they look at your long history and they summarize whether you have that interest.
So for each user, they take 2,000. Your last 2,000 videos. Am I getting it right? Your last
yes
2,000 videos, and then they have an attention, a cross attention on top of that. Is that what's going on here?
Exactly. They have a cross attention using 128 learned query vectors on top of that.
I see. Okay.
Right. And two blocks of that. So the learned, what is the key here is, while in the short-term pathway, the input was 20 and output was 20. But in the behavior compression or lifelong pathway, the input was 2,000 or could be even more, but the output is 128 times the mode.
Yeah.
Okay.
Yeah.
So essentially, this is more what is already known in the world of state-of-the-art recommender systems. That, hey, in fact, they also mentioned which papers this comes from. This Q former, I think, yeah, I forget previous
Yeah,
nomenclature.
I'll need to
Yeah,
do more research on that.
yeah.
I haven't dug into it.
I think this is the paper,
You've read that? I haven't.
Twin V2, um, scaling ultra long user behavior. But suffice to say,
And that's a very interesting. Not even interesting. I mean, that's a current problem among a lot of recommender system at the
yeah,
moment, because
yeah,
we have all this history, long histories. So the question is, how do you plug that in into even if it's the final stage ranker? Because if you use that as a feature, I don't know how well that would work.
yes, yes,
That
yes,
would have
yes,
a
yes,
fit.
yes. If I remember correctly, this is for a final stage ranker. But yeah, Twin V2 is
Yeah,
Q former. Yeah,
I'll make sure I go through it.
yeah. Oh, shoot. So, so coming back, the main part that we talked about here was that the user encoder. So, whatever they did, they encoded different parts of the history differently, but they concatenated it. What is this? Concatenated it, and you have positional encoding. That means when you use cross attention after this in the decoder, you see the decoder is going to do cross attention over Z-enc. Z-enc is this thing. Okay.
Sorry. So ZN is the short term and the long term
All of
concatenated.
them concatenated with
I see.
positional.
Okay.
So think of Z-enc as a sentence kind of, or a context,
Yeah.
which has these histories in specific positions, which allows your decoder to, kind of index right into.
Yeah.
So that's it. So this part, the generation is.
You know what? Just a quick note. I wonder whether
Yes.
this concept can be used in a normal, not the current paper we are discussing. I wonder whether it can be used in a normal ranker, final stage ranker. If you can make a module, or in the model which can do
I
something.
think so. I think so. See, what do you need in the final stage ranker? You need a way to process the history, but you also need the specificity of the history so that you can do target attention.
Correct.
And you have that. You have, like, in the short term one, you have the specificity, and the long term one is just summarized so that you can you're not forgetting any of the long term history. So I think this is a
Right.
great. Yeah, I think it's a great way to late stage ranking.
Yeah.
Yeah. How this part needs to change for traditional late stage ranking is
Which part?
so this part, the generation, the decoding rather.
Oh, I see.
What
I
it's
see. I see. You know what? I'm thinking if you just concatenate the summarized,
yeah,
the summarized H1 H2.
yeah,
I'm thinking after that probably you can try a self attention and then pass it on to
yeah,
any other component, because the generation part is not gonna work in this case because we don't have
yeah,
a coder.
yeah,
So I'm
yeah,
thinking even that might contain some information,
yeah,
because the
yeah,
whole problem statement is how do you put in a history of 2000, because
yeah,
the current procedures right now are a little bit shaky.
yeah, yeah.
Yeah.
Uh, in terms of what they do, they actually stick very close to our prototypical LLM definition. You have encoding that goes into the summary, and then there's a decoder which does cross attention on the summary and causal
Yeah.
attention on the generation, and teacher forcing and all that for training. So now that brings us to the second question. So practically, they didn't change much from Tiger in the user encoder. Like, they do a few things differently, and I think they're better, but like almost not the point of encoder decoder.
Mm-hmm.
Could have done that separately.
Mm-hmm.
So The main things they change are in a better tokenizer and the improved reward model.
Yeah.
All right, and that brings us to the second question, which is the reward model. There are three parts. Actually, I'm not going to go into the writing. I'll explain
Yeah.
to you what they're doing.
TLDR is okay.
Yeah. So this part, there's a nice paper, Pantheon paper, which sells it as traditionally you have the ranking model actually not doing ranking, but doing estimation, and a value model doing the actual ranking.
Which is true.
Yeah.
Which is true.
They
That's a true statement.
So they change it into the model actually doing the ranking. Why? Because they have a single score that is getting BCE loss from all the tasks. Actually.
Oh, I think I know the paper you're referring to. Is it Patreon?
Pan- Pantheon, yeah. So
Also, they incorporate this into that. That's what
yes,
we do.
yes,
Wow.
yes,
Okay. Well, then this paper, there's a lot to it.
yes, exactly. And
Yeah,
and
there's
then
a lot to it. There's a lot to it.
so this is a great way for them to get a single score
Yeah.
that captures the reward that is normally done in the value model.
Mm-hmm.
Because if you remember, in Pantheon, they say we're going to come with a single score, and you just sort by that, and that's great. That's actually better than your value model, which means
Right.
that score is the reward, so to speak. Right?
You know, the only parts I think I might not have agreed with the paper is one place. I thought to myself, from a business perspective,
Yeah.
that might not work so well, because let's say you want to boost certain sort of short, content you want to promote, because
Yes.
traditionally it's not being promoted, or for
Yes.
whatever reason.
Yes.
I because the model is objective. I mean,
Yes.
so
Yes.
I don't know whether you have a chance to do heuristic, although maybe you can argue you can still do that. You can still boost the scope. I'm answering my own question. I think you can still boost whatever score that comes out.
So I'll tell you what they say, and then
Yeah.
I'll tell you how I am thinking about the Pantheon paper. First, they say they talk about three rewards.
Mm-hmm.
One is the reward we just talked about, the single score Pantheon reward,
Mm-hmm.
right? Then they talk about this format reward, which is just one if the semantic IDs you generate is a valid semantic ID,
Mm-hmm.
and like zero if not. And they say why it was useful. It's basically once you start doing some sort of reinforcement learning based on sort of rewards you're talking about, it seems to incentivize the model to create incorrect or illegal like combinations, and they need a way to balance that. And this is exactly what you meant, business needs.
Yeah.
Right? So imagine, and they give a specific example. Imagine you don't want clickbaity videos, or like you want to. There's a certain dimension that you want to control to a certain point. Like, I don't know. Let's say you want to make short videos, not more than 25% of your platform, or something like you want to increase the timeliness of the content or recent content. All of that you can capture using a reward. Not differentiable, but at least you can have.
I see
Reinforcement.
what you're saying. Yeah, I see what you're saying. Because in the paper, which you just referred to, there's a place where I think gradient is not flowing backwards. Right?
Exactly.
I see.
Exactly.
I see.
Exactly. This is the part which is trained through reinforcement learning, and for that they take a variation of there's this. Have you heard of GRPO? I read that recently, and I think it's a variation of proximal policy optimization PPO.
Yeah.
So yeah, this
all those are like what people are raving about in LLMs.
yeah. And they make a change for this early clip here, something related to, oh, we will not give too like sometimes they say, oh, currently we're giving very negative losses and it's hurting the distribution and we're going to clip it. Something they found useful. But what the reason all of this is needed is because of the reinforcement learning based
Yeah.
loss. Right?
Wow. I mean, there's a lot to this paper.
There is a lot. There's a lot. There's a lot.
I'm wondering from an implementation perspective. Because if you said, let
Yeah.
me implement this whole thing, for example,
Yeah.
for my use case, I
Yeah.
wonder whether there's a way you can maybe modularize this
Yeah.
such that you can track it, like, you know, instead of the whole thing.
Yeah.
Because the way it sounds like, if you don't do the whole thing, you won't get
No.
the benefit of it. I'm wondering whether you can have like milestones and then feed into whatever system which is currently operational, and then you keep building on it. I'm wondering whether that's something possible. I don't know.
Exactly. No, exactly. That's the great question. Milestones. So again, focusing on our trending implementation, trend recommendation implementation.
Uh-huh.
Firstly, I want to add a disclaimer, or a rather realistic point, that even after all of this, okay, actually it's the end. If you see, 1 second. So remember, our pitch was that, hey, you don't need multiple stages. You can just generate.
That's correct.
And
You don't need a cascading system. Yeah.
they actually show that if you do have a cascaded system, so first they showed that the single system is good enough. Like, actually, it is better than the current cascaded system. Okay,
In
this
terms
point.
of
So OneRec
yeah.
compared to the current production shows improvements.
Okay.
But if you take OneRec and take the top 128 items, but after that, you still do your ranking model and value model.
Oh, I see. Okay. So in a way, this becomes like a generator.
Yes.
Okay.
And not a generator, only generator, but yes.
Yeah. Okay. Okay.
Yeah. So this is actually.
That's these are some good metrics.
Yeah. Yeah. Exactly. So these are like huge, right, compared to.
Oh yeah, 100%. I mean, for example, I can see on the P
Yeah.
OneRec is -2%. This is +2%.
Yeah. 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 So it is not the case. They're not saying that, hey, we are already at a point that there is no need for another layer. We're working on it, but we are not there yet.
Yeah. Yeah.
But the reason I say it is because this can help us in devising our milestones. And I think for friend recommendation, the minimum you need, go back to the blog, the minimum you need is you need to do this collaborative loss and all that. You need to tokenize for friending.
Yeah, that part for sure.
Yeah.
Yeah.
I think other problem is just because we have very few, the overfitting, like just because we have very few examples, you should add more losses. Instead of just taking the loss just from the target, you can splice your user history and create more losses. Like, use history to position I and try to predict I+1, things like that.
I see. Because your CTR is very low.
But yes, exactly, because your CTR is very low, and typically you have billions of videos being watched, but only
Yeah. So
But
this might prevent the model from becoming a little bit powerful. Although I would say though, if you can use this as a version 2 they are showing,
yeah,
you would think this, even if it generates not very accurate ranking, the recall will be high. I think so.
you're right. I think, to answer your question, what is the absolute milestone? First, I think you need some sort of tokenization.
Yes.
And if you get this tokenization, even if you don't use all of the reward models,
Yeah.
like even if you don't do the reinforcement learning part and you just have the Pantheon part, you need some reward because without a reward, you just cannot. Um, where is this? Where is this our reward? Yeah, you need. I think you need this reward because without that, you see the problem is traditionally you do a ranking model where you do estimation. Here you're not doing ranking. So you need some reward model.
So I would say this: if you can convert the first part of where you, I mean, I can see what you're saying, because even to convert the users into embeddings or to code books, you still need to do training and all, right? So you
Yeah,
do need something to optimize on, like to.
that's in the codebook generation. But I'm saying, like, when you're training your encoder decoder,
Mhm.
um,
How about you just train your decoder though, if you can?
yeah, that is what Tiger did. You just train your
If
decoder.
you, in fact, if you train your decoder right now, if you told me I have this decoder right now, then in essence, you can easily convert this into RQVA, because all now you have to do is use a normal transformer
Yeah,
and train it. Yeah. So that could be a shortcut, although you're not benefiting from all these other components, which I think are very important. Although for
no, I get it.
milestones,
Yeah,
that's something, because with a transformer, you don't, you just take the existing architecture, you're not changing anything.
got it. You're
Yeah.
saying in terms of for a milestone, first figure out how to tokenize. Let's assume that is
Yes.
table stakes.
Yes.
But after that, your first milestone can be just that. Like, you write your encoder decoder
Right.
using your semantic IDs and use it as a generator.
Yes.
Yeah,
That could be your past part, because the other parts, especially for friending, it can be complicated. Well, no, I won't say complicated, but there's a lift.
it's a
There's,
lot of work. Yeah,
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 there's some edge effort
yeah,
needed
yeah.
there, and a lot of iterations which might be needed.
Correct. Yeah,
But
yeah,
for generator, not so much of iterations, because the majority of heavy lifting will be done by the final stage ranker.
yeah,
Once
yeah.
you do your once you make this, you can measure the recall pretty fast.
Fantastic idea. So you're saying generate a first milestone, make your tokenizer, train your encoder decoder, and inference, and
Yes, and
yeah,
then get your recommendations around the number you
yeah,
want.
yeah,
And then now, once that piece is complete, you can
yeah,
build on it. Well, this
yeah,
is, you find a way to productionalize this, and then you can build on top of that. Because if you took this the way it is right now, if you are to implement even a simple MVP, from the discussion we've just had,
yeah, yeah,
it's not,
yeah. It's a lot of
yeah, there's a lot to it.
so I think this is probably the order you're talking about. So one, you figure out your tokenization.
Yes.
You have some implementation. You need
Hmm.
some implementation of encoder. You need some implementation of decoder.
Yeah.
But this is where you stop. And then,
Yeah. Stop right there.
yeah, next stage, you try to figure out a reward model.
Yes. Yes.
Perfect,
I think that would be the right approach.
perfect,
Because
perfect.
number four, in fact, number four,
Yeah,
that's where a majority of iteration need to happen,
yes, I
especially
agree.
on the reward.
I agree. I think, um, yeah,
And in
like,
fact, it might be easier to even do a proof of concept. Like, you can get people excited about this, or leadership, or anyone you're trying to
yeah,
propose this to.
yeah,
You can get them excited by, okay, we can have this component, other than saying we'll have to
yeah,
wait for possibly a quarter, or even
yeah,
more, for this to
yeah.
be generated and deployed and all that.
Yeah, absolutely. And I think specifically, like based on some of my experience, I mean, the probability of the the overfitting aspect that I was saying, because trending has very little data.
Yeah.
Don't worry about four. Even with between like just training two, just training the encoder can be fairly non-trivial.
Yeah. Yeah. Yeah.
Yeah,
And
absolutely.
yeah, but in terms of overfitting, because I was thinking of, as we were talking about the long history and the short history,
Yeah.
I found that quite interesting. Um,
Yes.
that's something which
Yes.
it wouldn't. I'm not saying it's trivial, but it wouldn't need a lot to try that. Just
I
that,
see.
just that aspect, not the rest of the paper. Just that aspect of
I see.
capturing short and long, concatenating, and
I
then
see. I see. I see.
yeah, I thought to myself, man, this is pretty good.
I see
Because
what you're.
to your point, let's say I could be following long term, I'm following people I know, like I know from school, college, things like that. But short term, I'm
Yeah.
more interested in, let's say I started traveling, so I'm following creators who are, posting content about traveling. So if you can capture that part and also have a way to summarize my long term, how I friend people, that will be quite powerful.
Yeah.
Especially if you're able to summarize it and reduce the sizes with the D model part. If you can be
Yeah.
able to reduce that and apply some sort of attention, I actually like that idea a lot.
That's a good point.
Yeah, I absolutely love that idea. That wouldn't take much of a lift to implement.
Yeah. I feel just based on my intuition, I also feel that the user encoder that they have here, while
Mhm.
it is a combination of ideas in previous papers, but I think that really helped them reach their milestone or at least, parity above the current model. Like it's a really good encoder.
Oh yeah, you can. I mean, you can tell this is a combination of papers. That's what I'm
Yeah.
saying. There's a lot to digest here.
Yeah.
Yeah, it's a combination of they take a little bit of piece from multiple papers,
Yeah.
which
Yeah.
is good, which is actually
Yeah.
very good. Yeah. So
Yeah.
if you could also do the same, I would think
Yeah.
this can be very helpful. Like take because the problem is always convincing stakeholders when you don't have something to show for it. But if you tell somebody like oh, we've already tried this aspect of this and here are some of the gains we've gotten, it's a little bit of an easier conversation to have than just
100%.
saying this is a proposal I'm thinking of. And I can imagine not so many people have tried this, so you don't have a lot of reference. Like not so many
Absolutely.
people, companies. I don't know. Maybe
No,
other
no,
than
no.
the others of this paper,
Yeah,
I don't know.
exactly. Like I think
Have
you're
Google,
empathizing with.
have Google say something about this paper?
I I think they publicly talked about how it is recommending how it is contributing to 50% or more of the YouTube recommendations.
Yeah.
Um,
You know
so
what? I could see that. I once had a conversation with somebody as well, senior in a recommendation system, and he was arguing that one of the reasons why we are not seeing sort of a step change in
mhm,
recommendation system is the problem lies with the cascading system. Because let's say I work on retrieval and somebody work on early stage ranking and somebody work on final stage ranking. The value model which I have on early stage ranking versus somebody else on the early stage ranking, I'm optimizing for something different. They are optimizing for something
yes,
different. That
yes,
disconnect becomes an issue. So having a step change will be very difficult with Rexis if we continue that route. It doesn't matter how you improve one aspect. Like you can
yeah,
have a big, for example, with LLMs, And he argued the same case. He argued with the same concept. He told me if LLMs, we did not like combine all these multiple pieces, the decoder and the encoder decoder, we would not be where we are if we did what we used to traditionally do. And I sort of agree with that hypothesis. I agree with that premise 100%. If we could, if this would work out, then yeah, there's a lot which can be done on this as
Yeah,
opposed to a cascading system. You can only change where you are.
yeah.
So
It's actually a good topic for some of discussions we were having about RAG and like
yeah,
but
yeah,
yeah, maybe over coffee.
yeah. It's quite an interesting. But yeah, I found this paper to be, first of all, it's not very easy to digest. There's a lot.
Yes.
Because I remember printing it and I thought to myself, there is no way a paper can be this big. There is no way.
Yeah.
I might have printed the wrong thing. Only to find out this paper has
Yes.
like a book.
Yeah.
So,
Yes. Even in like the 27th page, like for instance, in the ablations, they talk about the results of how in the user encoder
yeah,
they switched to using the semantic ID, and they're seeing some benefits, but they kind of that's work for another paper, etc. So like there was a lot of detail, even in the appendix, sort of.
yeah, I see it. Yeah, the place where they was talking about hash functions and then
Yeah.
the hit and the miss.
Yeah.
Yeah, so and that's what I was saying. If this can be the architecture going forward, I see a lot of things which we can do to change, like to do these little changes or to get good changes for Rexes.
Yeah.
I think this is the right way to go.
Yeah.
Proving it is and that's why I was saying if you could have some sort of milestones where you can discuss with somebody, or you know what, we've already done this piece and
Yes.
gotten these
Yes.
gains, it becomes
Yes.
an easier conversation. Because
Yes.
right now, for
Yeah.
example, if I was to take this paper and tell somebody who's been doing ranking, or we need to combine to
Yeah.
get rid of Alicia's ranking, retrieval, and combine,
Yeah.
they will be thinking I'm
Yeah.
out of my mind. Maybe.
Yeah. 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 No, that's what the industry is going through. Many teams. It's very hard right now. This paper. Many teams are trying to figure out the path to this future.
I think the path is what you and I have discussed in the last, like in the last
Yeah.
section,
Yeah.
where we were saying just implement section, just like
Yes.
we were talking about. For example, RQVA, VA was the right step towards the right direction,
Yeah. Yeah.
100%, because
Yeah.
you implement that, you show
Yeah.
how important this is,
Yeah.
and then you continue in that direction.
Yeah.
Yeah, because implementing the whole thing again,
Yeah.
as I was saying, it
Yeah.
can take time and a lot of iterations, especially if you're getting rid of the value more part.
Yeah. Yeah.
Then yeah, absolutely, there
That
will
is
be
huge.
a lot of
You're right. You're right. Oh my God. Yeah.
iterations you
Because
need to
so
do.
much. Yeah. So much business knowledge is captured in the balance of the value model that it's.
Yeah, yeah. So for
Yeah.
you to come and propose, in fact, I would argue if somebody were to try the Patreon paper,
Yeah.
there will be a lot of iterations needed just for that piece.
Yeah.
Yeah, just for that one piece. Um,
So maybe this is a good, think about it this way.
yeah,
Maybe a good first step is the generation retrieval, like you said.
yeah.
And separately, we work on the Pantheon paper or the user preference reward in
100%.
the.
Yeah, yeah. It's a dual playbook.
Yeah.
You have milestones for both. You have milestones for retrieval, and you have a milestone for the value model part, because that I to me that is where the most of
Yeah. Yeah. By the way,
um
the Pantheon paper, the single reward, like joining, ranking, value model, you can do even without
Yeah, oh
your
yeah,
generative retrieval.
100%. Even with the current system,
Yeah,
you can implement it. Yeah.
yeah,
So I would say somebody to iterate on that, because that
yeah,
part needs a lot of iteration.
yeah.
Um, and then somebody else in parallel
Very
works
good
on
point.
the retrieval.
Very good point. So,
Yeah.
so I
So
think what you're saying is look at this as a vision, then
mm,
break it into two parts. One is the generative retrieval.
yeah,
Second is the, let's call it the value model reward.
yeah.
Learn these first
Mm-hmm.
and then combine them, then try to combine them into an
Yes,
end-to-end.
because at that point, the middle aspect of it is
Yeah,
it's not that complicated. I'm
yeah,
not saying it's
yeah,
trivial, but I'm saying it's not compared
yeah,
to the business
yeah,
aspect of it.
yeah. No,
Because
totally.
basically, you're trying to encode a lot of information in that reward model. If you think
Yeah,
about it, like you
yeah,
are trying to do a lot there.
yeah,
So for you, even if you get not even if you get you don't get any gains. You just get how do I say, like, even if you don't get any sort of movement in metrics, you just get
yeah,
flat metrics. That's fine.
yeah,
That's
yeah,
what you
yeah,
need.
yeah,
Yeah.
yeah, yeah,
Then you
yeah,
know for sure, okay, this part works.
yeah,
So if we can improve the other one, for
yeah.
sure these metrics would go up. In fact, that
Sounds
probably should be the target, just to get balanced metrics.
yeah.
Maybe that should be the target.
For the value model part, certainly, yeah, yeah,
I would think so, because straight up getting gains from it without implementing the other pieces,
yeah.
yeah, that becomes, yeah, I'm just trying to think yeah, that would become very complicated. But if you can just get neutral metrics, then for sure you can say this piece is okay. So
Yeah,
if we improve on the other
yeah,
piece,
yeah,
then for sure we get metrics wins.
yeah.
That's how I would approach it.
That's a good framing. Yeah,
Yeah, that's how I would approach it. And anyone would be comfortable with that. If you say, "Oh, these are neutral metrics, nothing, nothing regressed, perfect." And in
very
fact,
nice.
you do also, if you get neutral metrics, you also have a case for engineering hours.
Yeah,
You can say we can relocate this engineering
yeah,
effort towards something
yeah,
else. So you
yeah,
have a case there. So in fact, I would say that's the aim should be neutral metrics,
yeah,
really.
yeah,
Because if you
yeah,
try to take metric wins, that will be that will be difficult.
yeah.
Yeah.
No, it's
So
a great,
if
great
you could
blueprint.
yeah, if you could just get neutrals and then argue, okay, if we ship this, not only are we getting, we are not hurting anything, but we are also going to, reallocate these engineering hours
Yeah,
to something else. Anyone will be,
yeah, yeah.
there is no one who would argue against that. That's at least how I would see it. A dual sort of playbook.
Sounds good. Just to recap, we look at the end-to-end vision
Yeah.
of generative retrieval, which has tokenization, encoder, decoder, and reward model steering, particularly the product inside. But towards implementing it, first we try to just do generative retrieval with the just the softmax loss of
Mm-hmm.
the right tokens,
Mm-hmm.
and then in parallel we work on the user preference reward. Also, we called it the value model reward. That's a standalone project that has to sort of first earn its neutral metrics at
Mm-hmm.
least,
Mm-hmm.
and then we combine both of them into into a combined end-to-end system.
Yeah, yeah. If you came with that proposal, no one would argue against it. Like no one would because most people most people don't like when a lot of things change all at once.
Yes, 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 yes.
I found that most people do not like that at all.
All right, cool. Let's
Perfect.
close this, but this was very good. I think the blueprint that you talked about, how to actually implement it, a lot of people are thinking about it. How do you make this leap towards generative recommendations from cascade
Yeah,
system?
because for me, I'm thinking whenever I, and you probably know this, but whenever I look at some paper or something cool, I'm just thinking of, okay, this is good, but how do I implement it? Like, how do I
Yeah,
put
yeah,
it in prod? That's all I'm always thinking of. Like, how do I
perfect.
put this to work, and then so that I can see, um, the results.
User impact. Very nice. Very nice.
Yeah,
All
so
right.
if I can see impact from it, then I'm thinking, man, this was pretty good. And then if we can't, it's okay. It's a learning experience. You learn this probably is not for friending. Or not even that. There's a lot of components on this paper, to be honest,
Yeah,
where even if you don't end up implementing this whole system, you can
yeah,
borrow a lot from this. You can
yeah,
borrow a lot. Yeah.
yeah,
Like
yeah,
that sequence, the long user
yeah, yeah, yeah,
composition, I thought, oh my God, this is amazing.
yeah.
Yeah, this is amazing because you solve issues of more of a feeling just like that. I saw this article, and probably when you get time, you might want to read it. I think it's by TikTok. It's called Deep Retrieval. Deep Retrieval or Retrieval?
Deep retrieval. Yeah,
Yeah, I think they were doing something to do with k-means. And when I was reading this paper, I kind of started to associate what they were doing with clustering with with uh, with this.
yeah,
I,
yeah.
I thought they were kind of almost going to that direction.
I'll read sometime. Well, let's keep it for another
Yeah.
session. All right, cool.
Perfect.
I'll stop
So
recording.
what's up for your afternoon?